Hey everybody, this is Alex Merced and welcome to this subsurface presentation in transformations, best practices in Dremio. The point of this presentation is going to be to basically establish the importance of really being thoughtful about how you transform your data from your raw data. Okay, and then afterwards we'll do a small demo just kind of illustrating some of these ideas and practices and why they matter. But let me just introduce myself for those of you who do not know me. I'm the head of DevRel here at Dremio. I've gotten to talk about data lakehouses, Iceberg, Apache Arrow for the last 4 years at many events like Data Day Texas and Data Council, and have gotten the honor of being the co-author on several different books like Apache Iceberg, the definitive guide, Apache Polaris, the definitive guide, and this joint effort that Dremio had with MinIO, PuppyGraph, Fivetran, Confluent, Apache Iceberg, Digest Volume 1. You can get download all these books for free by scanning the following QR code. Okay. Generally, you can also just go to dremio.com and find all of these throughout the website. But bottom line, when it comes to reliable sort of data work, so bottom line is that whether you're talking about you're creating a BI dashboard for people to kind of see what's going on with the business, creating AI agents that can use your data to optimize and automate workflows, or just doing ad hoc analytics, all of that's really going to be based on having well-structured data, okay, and actually having a semantic layer. Now, let me just talk a little bit about that word semantic. Again, the word semantic just means a meaning. It's the layer that has meaning. So generally, when we're talking about doing transformations, it's really working our way up to that sort of version of our data that has the most meaning, our semantic layer, the version of the data that our users work with. Okay. But there's several steps that go in there, not just imbuing sort of meaning in the sense of business logic, but also making sure that the data is cleaned, and basically that way you're not having to process duplicate records and reduce a lot of the processing you have at the end of the time. Okay, having sort of very simple, clear sort of transformation logic can help lower sort of your maintenance because you're not having to do as much duplicate work and cleaning data at the last mile. You can, and also having a lot of shared patterns imbued in your transformation, so that way different teams who are going to basically make the same changes aren't doing those changes again. It's going to be very valuable. Okay, so bottom line, the idea here is in your transformations is you want to kind of think through what are the different pieces of changing the data that are going to happen, whether that's data cleanup or again imbuing sort of business logic semantics into the data. Now, Dremio is going to offer lots of tools to make working with your data a delightful experience, whether it's our high performance SQL engine, our first class Iceberg support, where you can basically read, write, govern, maintain Iceberg tables all in one platform alongside your databases, data warehouses, and data lakes. Our acceleration features that feature things like reflections, our table optimization features, our caches, things like that. A new thing that's been introduced recently, there's been a library that went into PyPy called the Dremio Frame that makes it really easy to work with Dremio using Python. And again, just all these tools such as our views and tags, particularly the views that are going to allow us to do transformations without necessarily having to physically duplicate our data, helping us reduce that storage imprint, allowing for a much more efficient data lakehouse. Okay, but whether you are using views to do your transformations, meaning instead of creating another physical copy of the data set, you're creating a SQL sort of view of filter on the existing raw data, or if you're just doing actual physical copies where you're basically manifesting sort of another Iceberg table that's the cleaned up version of your data, you're still going to want to sort of think through the steps that you go through. Okay. So bottom line is generally first thing you want to do in your sort of first transformation is sort of redo scan data. So think about like first, let's create a version of the data that just grabs all the fields that I need. Okay, that filters. Because again, the earlier you do the filters, then later on when you do joins, sorts, aggregations, that's going to be a lot less processing because you're doing it on less records. So you always just want to have your filters first, and then you're joined in aggregation. So if I were thinking about like doing the SQL view approach with Dremio, where generally you create SQL views for sort of each step, I would first do the steps that do filters on my tables to before I start doing the versions of the views that would represent the joins. Okay. At the end of the day, like for example, push down logic into your source systems when you're doing those filters, so that way you don't have to transfer less data across the wire. So for example, if you have a Postgres source, if I know that I can have some of the filtering logic happen down at the Postgres layer. Dremio, of course, will try to optimize pushdowns for you, but there's also a feature called and a function called external query where you can design, if there's specific business logic that you may know that you can already apply at that pushdown level to filter out records you don't need, you can use that external query feature to then again pull less data from Postgres. So that way Dremio is only transferring the data it needs, which is again going to save time in the processing. Avoid select star queries. Okay, you'll see me do sometimes select star queries for demonstration purposes, but in general, you're going to make everything up. Even if you're using every column, you're going to end up making it do more work. Okay, and it's going to slow down processing. So type out the names of the columns that you actually need. Okay, now keep transformation close to the original data to avoid extra layers. Okay, essentially that's the idea here is don't duplicate your data. Okay, so this is the beauty of like with SQL views, where you can create these step views that kind of step to your final transformation without necessarily having to duplicate the data. So you can create a view that does cleanup work, and then from that view, create one that does some filters and then after that, then create your joins. And so that way, each layer you can go back and the amount of logic that's in each step is very clear and simple. So that way, when you go back, because if you try to put all your transformation logic into one sort of SQL statement or into one view, you're going to get one view that's going to be really hard to maintain, really hard to troubleshoot. So again, just sort of doing it in steps and having sort of a clear sort of, hey, what steps am I doing this? So first you have your raw data, okay, which you might keep in sources like Postgres, or you might move over to an Iceberg table. So again, there's a logic of how you do that. Okay, so what is the SQL query you use in Dremio to take the data from your Postgres and move it into a table, and what sort of pushdowns you put into there? Then what is the SQL query from that view you use to clean the data? Then what is the SQL query you use to filter the data? Then what is the SQL query you use to join the data? But again, do it as multiple SQL queries instead of one large complex query, so that way you end up creating less layers. Okay. So again, a simple filter and projection reduces scan data. So again, the less data you're pulling in over from your original source, because you filtered first before joining, the more performant those joins are going to be. Okay, you're scanning a narrower amount of data because of the filter. Okay, you can also, again, if you prefer a more programmatic approach, you can use the Dremio from Python library to be able to kind of generate SQL using a more Pythonic sort of interface. So again, you can see an example here where basically we're querying the lakehouse.sales table, and we're selecting particular columns and filtering in a certain way. And again, you do it in a way where basically it makes it harder to make mistakes in writing the SQL because the SQL is being generated. It's just going to take in sort of the variable parts, and then that way you don't accidentally like write, make a typo in writing, where or something like that. A lot of that stuff just gets kind of automatically built out for you in the SQL and then sent over to Dremio. Now, the end goal is to get to that step where you have a view of your data. So again, in Dremio, we generally recommend that you try to do as much as you can using SQL views. Again, because you're going to reduce the amount of storage of your data. And then you allow Dremio's acceleration layer to kind of figure out what needs to be materialized and what doesn't. Okay, and that's the beauty of Dremio in the sense that you don't have to materialize everything to have performance. Dremio will figure out sort of what are the bits and where are the different points within sort of your semantic layer, within that sort of graph of sources and tables and views. What are the things that sort of need physical replication based on the queries that are coming in? So basically, you can just focus on, hey, what is the logic that I want to step? What is the logic I want for filtering? What is the logic that I want for cleanup? What is the logic I want for joining? What is the logic I want for building out sort of dimensional models? And then what is the business logic I need to imbue for my specific use case views? Okay, but you do it all through SQL views. Okay, and then eventually you're going to have that last layer, that aka your gold layer or your semantic layer. And again, so semantic layer can be used in a couple different ways because of just the history of the word. But oftentimes there's like the semantic layer product, which is the feature within a platform that enables you to define business logic. So in Dremio, the semantic layer is the fact that we can create this graph of SQL views, create wikis, all these things that allow us to document and define business logic and business terms and things like that. But then there's the concept of the semantic layer, which is again the versions of your data that your business users are going to use. So oftentimes that's going to be that last layer, that gold layer of data, which is going to be the version of your data that's going to have the column names that are most clear to your business analysts, that are going to have a lot of the sort of different types of metrics that they're going to be looking up, already kind of predefined using sort of the business's standard definition of them. Um, and that's the beauty of having views in Dremio, because again, any BI tool, any AI agent, any pretty much any data analytics tool can connect to Dremio to pull those standard views versus redefining them in some sort of other tool where it's those definitions that have to be replicated across multiple tools. And again, having all that logic defined within Dremio also is going to allow you to see the lineage of how your data sets evolve, because you'll have your raw tables at your raw sources in Dremio, and you'll be able to track the lineage of all those steps, those, each SQL view that creates sort of the next step in your logic will be sort of defined in the process. Okay. And this is going to allow you to, again, have a much more auditability of how your data is being transformed, allow you to replicate the data a lot less, because again, you're not physically replicating the data as much, and allow you to kind of create views that really create simple queries that make the logic for each step much clearer. Okay. So now, how do you create views in Dremio? Okay, you could just use SQL. Okay, right there in Dremio, we have a create or replace view command, and you basically say, hey, based on the SQL, create a SQL view based on this command. Pretty simple. Now, of course, you also have the option of using Python, where you can create a view using a SQL query that you've defined using the Builder API in that Dremio frame library, which would look something like this, where we would define the query, and then we'd say, hey, create a view from that query. Okay, and again, the nice thing about using Python is you can take advantage of automating Python, take advantage of other Python libraries, use sort of do it more dynamically by injecting variables and things like that. So it can be useful if you're someone who likes using Python as a way to interact with your data platforms. Okay, but again, one of the benefits of Dremio is, again, you don't have to physically replicate all your different layers of transformations. You can use views. And the way that's able to be kept performant, the reason you're able to do that level of virtualization at scale with Dremio is because of reflections. Reflections figure basically, there's two ways you can use reflections. You can manually use reflections, which means you define sort of things that you think should be materialized. So oftentimes you'll find maybe a view in your goal layer needs to go a little faster and you reflect it, aka create this sort of intelligent, automated materialization. Or you allow Dremio's autonomous reflections feature figure that out, and Dremio will take a look at your queries coming in, your jobs, and determine sort of not only what tables and views need to be replicated, but what columns in those tables, how should that be partitioned when it does that materialization, figure out what is sort of the optimal way to physically represent it to optimize your queries. Now, of course, reflections come in sort of two main flavors. There's raw reflections, which are more sort of like making a copy of the table. So you're making a copy of the individual rows. Okay. And again, it doesn't have to be a copy of every row and every column, but conceptually what they are is copies of rows. While there's aggregation reflections, which are more like roll-up statistics. So it'll figure out, hey, what is the average of this column? What is the min-max of this column? And then figure out that based on group by this field and group by that field, and create a table or materialization that has those pre-computed aggregations. And the cool thing about this is that unlike materialized views and BI cubes, where now your analyst would have to take this additional step of knowing what are these other sort of versions of the data that they need to use to get performance, Dremio will automatically optimize the performance of the queries that are already running with the reflections that were created. So the end user never needs to worry that reflections even exist. They'll just notice that things are faster. And again, Dremio will automate the addition of these things and the refresh and the removal of these things. So at the end of the day, all you have to do is focus on is creating your views, creating the SQL logic that defines your business data sets, and Dremio can focus on the materialization and the acceleration of queries on that data set for you in an automatic way, taking a lot of work off your plate. So here's an example of like the aggregation reflection concept. Basically, you have raw data, okay, and you want to like build a dashboard on it, okay. Basically, you're doing a lot of sort of min maxes grouped by this particular field here. So basically, you create the aggregate reflection, which kind of pre-computes a lot of that stuff. So now when you have like a BI report, that'll just get substituted out and basically reduce the time to execute that report. But again, you can create reflections using Python as well. All the admin features of the Dremio API are also built into the Dremio frame library, so you can use that there. So that way, if you want to manually create reflections, you can. You can see an example here where we're creating an aggregation reflection on a particular view. Okay. And again, lineage is a real nice thing, again, about keeping your transformation logic as much as possible in Dremio. Okay, in Dremio, we're really big on sort of like the ELT type of pattern, where basically instead of transforming your data before you move it, is basically connect your raw data to Dremio and then define the transformations after you've already connected it to Dremio. So so really the export, so you're exporting the data. And really, honestly, you're not even exporting and loading, you're just connecting the data sources to Dremio. And Dremio is going to have access to your raw data, and then you're basically defining the transformations via your views. But because you do that, you have access to your full lineage of transformations within the Dremio platform. You can audit what columns were changed, who changed them, what views create what transformations, allowing you that, again, that visibility. And again, this also enhances the Dremio's AI tools. So again, having a good, thoughtful transformations that are sort of well paced out, okay, that are thoughtful, again, trying to clean data, filter data, join data, and then inject business logic. Then what happens, again, you have this auditable lineage, but also all this data then gets brought into our MCP server to allow it to more intelligently, for the AI agent and your custom AI agents through our MCP server to more intelligently work with the data, okay, in these automated AI ways. Okay. So now if you want while in the Dremio UI, you can inspect lineage right there in the Dremio UI if you want. Again, there's also ways to sort of explore the lineage using the Python Dremio frame library as well. Here you can see some examples of that. Okay. But again, just some reminders of what we've learned. Again, you want to filter and project early. So the idea is you want to like reduce the amount of data you're working with earlier on in sort of the steps of your transformations before you do your joins and whatnot, so you can reduce the performance hit on joins. Okay, you want to try to do this as views, so that way, again, if you can create sort of like the different steps in views, they can be reused. Okay, let's say you have a transformation that's like 5 steps, but somebody else, their steps 1, 2, and 3 are going to be identically the same as yours. They can start off the view you have on like your 3rd step, and then they can build their own sort of path if their path kind of diverts from there. So you're not having to recreate the same logic as many times, because you're sort of creating smaller units of logic by creating separate views for sort of each step. Okay. So again, having sort of thinking through sort of how you do that is going to really help out. Again, allow reflections to be able to kind of handle the performance questions. Okay, so you either manually create reflections on views you think need to be accelerated, or allow Dremio to do it with autonomous reflections. Again, you have the benefit of doing this way, and doing it all in Dremio is going to give you that full lineage view, so that you have that auditability and understanding of how your data has been transformed. Okay, and again, you can either do it with SQL or you can do it with Python using the Dremio frame library. But with that, I highly recommend that you get hands-on with the Dremio Cloud, with a Dremio Cloud free trial. This tutorial that I have here, if you scan this QR code, it's going to take you to a tutorial where I want to walk you through kind of doing a lot of these things hands-on. There will be a demo that we'll be playing in just a moment. But again, this is a really cool exercise where you'll sign up for a free trial. You'll get to do use a lot of the features of Dremio, kind of get a good exploration of the Dremio UI, so that way you can better leverage Dremio. With that, again, follow me on LinkedIn. Also join the Dremio developer community at developer.dremio.com. So if you join the Slack community at developer.dremio.com, there'll be sort of a great way to get in touch with me. You can message me there at any time with any questions you have about the Dremio platform, but also a great way to meet other people using the Dremio platform and to share ideas, share concepts, share features, and all that good stuff. So have a great day. We'll have to let the demo begin. I'll see you all later. Hey everybody, I'm going to record this demonstration of sort of like transformation best practices, or just kind of showing you like how you could do transformations in Dremio. So again, generally the logic here is that you want to connect your raw data sources or land your tables in Iceberg, in Dremio's catalog, and then build views for the rest of your logic from there. So this is the sample SQL script, and then I'll show you the results. But basically here I'm just kind of creating the where I want to do all this work in my Dremio catalog. So I created like a clinic data folder with a raw silver gold subfolder from there. Now essentially the idea here is we're gonna have a couple of raw tables. So we're creating our first raw table, which is our encounters data. Okay. Then we kind of see that with some data. Now this data purposely has some mistakes, some duplicates, stuff that needs to be cleaned up. Okay, so that's our encounters table. So like raw patient encounters table. Then we're going to have our raw lab results. So this is labs that these patients have had. And we're going to create the table, inject some raw data in there. Okay, so this is just setting up our raw layer. But really what you want to do is you want to take that raw data and you want to, well, turn it into something that's usable by the business. That's the whole concept of a semantic layer. The idea is, I mean, while again, as I've mentioned in the past, there's sort of the semantic layer, the product, which is, again, in the case of Dremio, the semantic layer product is sort of the ability to create views on your data along with the wikis and the lineage tracking. But then there's like what the sort of outcome of a semantic layer is creating a version of your data that's just sort of understandable and usable by your business level users. And again, if it's something that your business level users can understand, because it's using common business terms, it's applying common business logic, then it's going to be things that your AI is going to be able to take advantage of because it'll be able to understand the context. So anything that is going to make the data more usable by a human is going to make the data also 10 times more usable for an AI agent. Okay, so the value of semantics. Okay, so in our silver layer, one of the things I advocate for, or again, best practices for transformations, is doing it piece by piece. Don't put all your transformation logic sort of in one step, because you may have, then what happens is that you can't reuse that logic. So you end up having to do the same transformations again in other sort of chains of views, or even chains of transformations. So in this case, what we did was we split up all the sort of the cleanup and essentially silver layer transformation work into sort of three categories. First, we're going to clean the data. So here we're creating a view that cleans the data, looks for duplicates and such. Okay, so we're looking for duplicates and then cleaning out any nulls. So we have a view that just does that piece, the cleanup. Now, after we do the cleanup, again, we clean both data sets. Then we're doing a view that filters any unnecessary data. Okay, because at the end of the day, before you actually join any data sets, you want to just get rid of any records that you just may not need at all for the join. So that way the join's going to be more performant. So in this case, this view is filtering any additional records we may not need. Okay, and that's going to be, again, here's where we're starting to see sort of the first initial little pieces of business logic kind of sprinkle in there. Okay, so again, while usually you would want to do the joins before you inject business logic, there are going to be certain times where business logic may make sense to inject earlier. And that's why it was good that we separated the filter step, the cleanup step from this step, because we want the steps that are not business logic to be their own steps. We don't want to mix any business logic and non-business logic transformations in the same step, because there might be other parts of the company that might have to transform the data differently, and then they can take advantage of that cleanup step and build from there instead of having to rebuild that cleanup step. Okay, but so we go, we inject our sort of filter logic here, we filter both data sets, and now we can join the two tables. So then we create our last piece of our silver layer where we join the data sets and we're good. So we have our last view there. So now we can move on to our gold layer where we're going to actually create the views that are going to power BI dashboards, reports, agentic workflows. Okay, and we have different ones that we show up here. So we're going to have this HbA1c. So here we're taking it's a clinical quality metric for diabetic encounters. So we're going to take a look at the details from that test. So we construct that view. We have our ALOS by department. Again, an operational metric for hospital clinic capacity planning. That's going to be its own view in that gold layer. So again, we're just separating out the different metrics that we need that are going to be, and so that way that logic is only defined once between departments. Okay, payer mix summary. So here we're just looking at like reimbursements and revenue, and then we separate that out. Okay, I've already ran this SQL, so when we take a look at it in Dremio, so you see here I have my Dremio namespace. Within there I have my clinic data namespace organized into raw, silver, gold. And then again, I can see here's like my those gold sets. Again, you can see they're green, so that's going to means that they're a view, not a physical copy of the table. So I've not duplicated my data at all. Only copy of the data is that raw copy. And the cool thing about this is that now I've not duplicated my data. Now for other users who may only need this gold layer, I will create them an account and only give them access to these gold data sets. So even though they're still technically, fundamentally, Dremio is going to still query that raw layer, they don't have direct access to it. They only have direct access to whatever these views give them access to. Okay, and I'll just go run a query. So that makes life a lot easier. And then we can see like, hey, look, here's the data. Okay, now on top of that, so again, that allows you to govern it. That's another piece of of Dremio's semantic layers that allows you to govern these semantic definitions and say who has access to them. Okay, but then again, you can also take a look at things like lineage. So when I take a look at lineage for this particular view here, I can see exactly what we were talking about in action. How we had the two raw tables, and then again, little by little, we cleaned them up, we filtered them, then we joined them, and then we created the metric. Okay, now if I'm somebody who wants to then derive some other metric, I can take a look at this lineage chart and see, hey, where would be the best place for me to start? So maybe I don't need the same filtering, there's like little splash of business logic we had in the filter step, so I might then go look for that clean view and then build off of that. Okay, also just lets me understand sort of how this evolved. I can click on any of these to kind of take a quick look at what that data sets. So now I can see what this particular view's columns were, so I can kind of get an idea of which columns transferred over at what level. Okay, but again, I get this nice reflection. And again, this lineage not only makes it easier for me to audit the data and see my transformations, and again, it's much easier for me to understand the transformations in this step where basically there's clear steps in the way my views are organized. So I can actually, like, just in the naming of it, I can kind of see what happened. You know, we had the data, we cleaned the data, we filtered the data, we joined the data, and then we produce our metrics. Okay, so again, nice and clear, easy to understand, but then all of this data, this lineage data, the schema data, the any wiki data, that right now I can actually use the AI feature to generate a wiki if I want. Okay, so here I'm going to generate a wiki on the join, so it's going to generate that in just a moment. But I can do all that, and all that's going to get pulled into context when I'm using the Dremio MCP server or the Dremio AI agent to give you better AI results more of the time. Okay, so hopefully you guys enjoyed that demo. I'll see y'all later. Have a great day and enjoy.